Yes, my name is Tom Liptrot. I am a data scientist and a machine learning consultant. I'm going to talk about when AI goes wrong. Quick plan. So I'll talk a bit first about what AI is, just because there's lots of disagreements about that, and maybe not everyone, is on the same page on that. But I will talk about it and give a bit of a structure for how I think you should think about AI. Then I'll talk a bit about when it goes wrong, and hopefully a little bit about how you can make it go right. Before you get to AI, you need to sort of understand what we mean by intelligence. So if we can understand what intelligence is, then we can kind of maybe understand how you would build something that's artificially intelligent. So this is a video of a crow. Now, crows are really intelligent animals. They're about as intelligent as a 4 or 5 year old child or something like that. So they can solve quite complex problems. So here a crow has been given a tube with water in it, and floating in the water is a bit of food, and its beak can't fit it down to get into the tube. So it works out quite quickly that if it puts a rock into the water, it will increase the water level, displacing it, and bring the food up to a level that it can reach. So it goes about it quite systematically. It puts a rock in, tries to go and get the food. Can it get it yet? Need another rock. Yeah, one more. And then that increases the water level a bit. And can he get it now? And he gets it. So that's kind of, that's intelligent. Definitely. And there's if you go and look online, there's loads of videos of crows solving quite complicated problems where they have to sort of do lots of different steps and get through them and eventually, achieve their goal. And I think, if we could build a system that was as intelligent as a crow, we'd have built AI. I think so. That's kind of a good thing to have in your mind. So, but I've kind of think about this using these three factors that you might have in an intelligent system. And if you take one thing away if you take three things away from this talk, you take these three factors and they're helpful for understanding AI. That an intelligent system has got goals, it makes predictions, and it chooses actions. If it doesn't have any one of those things, it's not intelligent. So a crow has a goal, it wants some food. It makes predictions that if it puts a rock into the water, it will raise the water and it'll be able to reach. That's probably a prediction. It might be thinking something else, but it might, but that's roughly what its prediction is that if it does this thing will occur. And then it chooses actions. It drops rocks into the water in order to make the food rise up. So that's, it's an intelligent system. It can do those three things. If you could build a system that would do those three things, I think it would be intelligent. So if AI has those, if a system has those three things, it's intelligent. So let's now, what's happening there? Talk about some other systems. So I am perhaps an intelligent system. So my name's Tom Litcher. I run a data science consultancy called Ortom. So I usually work for startups and scale-ups, helping them to put machine learning and AI into their products in some way. So I kind of advise people what to do and then actually do it for them and build them things. So that's kind of my goal, is to help tech firms do that kind of thing. My prediction is that if I come to events and talk to people about these things, about things that interest me, I will meet interesting people, and that I may be able to help them in some way. And my action is to come and talk to you. So about what AI is, how can it go wrong, and some tips for making it go right. Some more examples. So I'll give a few examples here, and they're kind of going to move from quite simple to quite complex. So the first one is games. So one of the kind of most effective or archetypal examples of artificial intelligence is a system that can play chess or play a game. And these systems are really good. They're much better than humans at playing these games. And the reason that is because they're quite easy to define. There's a simple goal. You have to get checkmate, defeat your opponent. And you can make predictions. So your predictions are basically, will this move lead to a win? And if you make that prediction lots of times, and you always choose the move that's more likely to lead to a win, then you'll win. And so the action is that you choose a move. So in this case, all of your your goal, your prediction, and your actions are all very tightly coupled. Your predictions are explicitly about, will my action lead to my goal, and then your action is explicitly about achieving your goal. So it's a nice, closed, simple system. There's no external factors. You're not worrying about someone coming and throwing a board over or anything like that. So it's nice and easy. So that's kind of a simple example. Another one, which I think some people might question whether it actually is AI. I think it probably is a recommender system. So this is probably the single most valuable application of machine learning in the commercial world is the thing that puts your Amazon feed in order. So you get recommended products, you get recommended stuff to watch on Netflix, all of that stuff. You get recommended by Facebook what might be interesting to you. These things are intelligent systems, and their goals are usually to sell more stuff, to satisfy customers, to make more money. That's usually the goal. It's probably not even to satisfy customers. It's to make more money for shareholders in some way. But for like an e-commerce recommender, the prediction that you'd make is something like, what product will this user like, or what product will this user buy? And you can use machine learning for that. Now, machine learning, I'm not going to talk that much about machine learning, but machine learning is very good at predicting things. It's a mathematical technique for predicting things. It's good at that part of the equation. But if you can build a model that predicts what each user will like, then your action is you can choose a set of products to show that user. And if you do that really well, then you'll make loads of money. So TikTok is very, very good at this. They recommend a stream of videos that you might like, and that keeps people on it for ages. That's all TikTok is. It's an AI. It's with a weird goal of, I don't know, engagement, or some other goal that the Chinese government has given it. So yeah, that's e-commerce. It's big, and it's successful, and it's AI. Another thing I've worked on quite a lot is healthcare. Now, healthcare is hard, much harder than e-commerce to work on for various reasons. So one of the projects I worked on fairly unsuccessfully was toxicity prediction for patients getting chemotherapy in a cancer hospital. So it's trying to predict. Chemotherapy generally is really bad for you. It's not a fun treatment to have, but some people have very bad reactions to the drugs, and some people react less badly to them. If you can build a model that predicts, given all we know about a patient, whether they're going to have a good or a bad reaction to that treatment. That's the thing you can do. So you can do prediction. Your goal is safe, effective economic treatment of that patient. It's complicated, is what it's not like just making a bit more money or winning a chess game. It's very complex because there's lots of different factors involved. There's lots of people involved, lots of considerations. You don't have very perfect data. You can't just try things out randomly on patients. It's hard, and that's it's really hard to make things work. But you can build these kind of systems, and you can do things like if you predict that a patient is going to have a very bad reaction to a drug, you can give them a different drug. You don't always have different drugs available, or you can bring them in and monitor them very closely, and that's the thing that they do. You can't bring in all of the patients and monitor them closely, so you bring in the ones at the highest risk and monitor them and make sure that they're okay through the worst part of their reactions to the drugs. So that's an AI system. I guess typically that kind of system is like a combination of man and machine. So that usually the doctor is in the loop choosing what the action is. So that there's it's kind of a human machine intelligence, I guess. Another example, transport. So these don't exist. Self-driving cars don't exist. They're always going to be 20 years away for the foreseeable future. And again, the reason I think for that is that the goals are complex. Safe, fast, cheap transport is each of those terms, safe, fast, and cheap. They aren't absolute terms. You're not trying to increase safety to 100%. You want it at like 99.9 because driving around in a metal box isn't safe. It's not not entirely safe. It's not you can't go as fast as you possibly want because that's in conflict with the safety requirement. And cheap is a relative thing. It's always going to have some cost to do this. So your goals are complex, and you're dealing with complex systems like people's lives and moving vehicles. So the goals are complex and the predictions are complex. So you can make predictions that are of some relevance to a self-driving car, like what's that object coming up towards me? What will the other driver do? What are the road conditions like now? What are they going to be in a minute? You can make all these predictions, but then the actions that you have to choose are quite limited, really. They're just you've got the accelerator, the brake, and the gears and the steering wheel. So you have to take all the information from that big lump of predictions and turn it into something that you can act on. And it's really hard because these things don't feed back to each other, obviously. Like if you think about the chess example, it's very clear what the whole feedback mechanism is and how things, how a action impacts the goal. Here, it's impossible. Like it's hard for a person to do this, and I think that's an important thing to think about with AI. That AI is about as clever as maybe a 10-year-old child. So, and you wouldn't let a 10-year-old child drive a car. So, if a task is hard for a person, it's impossible for an AI generally. That's not always the case. Chess is a nice example where we're much better than machines are much better than people. But AI is pretty dumb. Okay, so that's I guess that's kind of an introduction. And all of those are just kind of examples, just to illustrate the range of different types of things that you can call AI. A lot of people sort of say, "Oh, it's just a marketing term, AI." I think it is a real thing, but it's complicated. But yeah, here I will present an AI horror story. So this is kind of based on a true story. The story you're about to hear is true. The names might have been changed a bit to protect lots of things. But before I get into the story, I'll give you a little story of what it's not. Okay, so you might think that an AI horror story might be a bit like this.
Hello, Hal, do you read me? Who you read me, Hal? Affirmative, Dave. I read you.
Open the pod bay doors, Hal.
I'm sorry, Dave. I'm afraid I can't do that.
What's the problem?
I think you know what the problem is just as well as I do.
What are you talking about, Hal?
This mission is too important for me to allow you to jeopardize it.
I don't know what you're talking about, Hal.
I know that you and Frank were planning to disconnect me. And I'm afraid that's something I cannot allow to happen.
So there's a clip. Anyone know what film this is from? Yeah, very good. So yeah, there's a clip from 2001: A Space Odyssey in which the kind of main AI computer, HAL 9000, rebels against the humans, and he decides that his mission is more important than their desire to know what's going on, and he thinks basically that if he kills them, it will kind of override the fact that he's not allowed to tell them what the mission is. So he's got complex goals, and he makes some predictions, and he does some actions by killing the well, he tries to kill the or he does kill quite a few of the people in the ship. So this is kind of, I guess, the science fiction version of when AI goes wrong. You know, you've got this super intelligent machine. It works. You know, it's intelligent. It can control the ship, and it has goals and makes predictions and does actions. But it goes wrong because somehow it's got its wires crossed, or its goals have been misspecified in some way. This is not how AI usually goes wrong. The way AI usually goes wrong is just it doesn't go anywhere. You know, somebody in a company, in a tech firm, somewhere tries to build something, and it just fails. They spend months and months working on it, and you end up with just a pile of data in a cupboard like this that nobody wants, and you get no value out of it, and everyone's very sad, and all the data scientists get fired. That's how AI goes wrong in the real world. Sorry.
Oh, help.
So this example is from a company that I did some work with a little while ago, who is runs a subscription. Is a subscription tech firm. It's not Netflix, but it does something a bit like that. So they sell some service, and that service is on a subscription basis. Most tech startups do some kind of SaaS model at the moment, with some recurring revenue, and they try and keep the users in for a long time. Now, this company had a bit of a problem with users leaving. A bit like Netflix. the users were leaving on a fairly regular basis, and it was kind of ruining their growth forecast because people were leaving all the time. And so they're a fairly small company, so they decided to hire a data scientist. Now this is where you should start to worry, because there's a data scientist. If you've got one lone, unexperienced data scientist in a company, they're usually not very happy people. So they and George, when I first met him, wasn't a very happy person. He'd been kind of locked away, given a sort of fairly ill-specified task to do and he'd been working on it for a long time, and it hadn't gone anywhere. It was he wasn't making any progress. He was unhappy. He wasn't well supervised, and he was thinking about leaving. This is the picture of AI going wrong. This is how, this is what it looks like. Nobody's building super intelligent machines that are trying to take over the world. AI goes wrong when it fails miserably. So what George had been asked to do was look into churn. And I don't know if anyone here has ever been asked to look into churn or model churn, but it's the thing that data scientists try and do very often. Someone will say, so churn, for anyone who doesn't know, is when you have a subscription business model and people are leaving. So they're leaving your service, and you're losing customers basically. So either they're not renewing, or they're actively cancelling. So often businesses think that if they can predict churn using machine learning, that will be a useful thing. So George had been told to go away and predict churn. And he spent, 6 months building a model that predicted churn. He'd spent a long, long time with all of these Spark pipelines, getting the data from different systems, bringing it together in this horrible, massive Jupyter notebook, and building something. And eventually he got, a CSV with some predictions in it. And he sent it to marketing. And they said, "Oh, thank you." I don't know what to do with that. It's a CSV with lots of, 16 decimal point precision numbers in it. We can't do anything with that. So this is kind of what he'd been doing. This is, I don't know if you've seen this from xkcd. So this is your machine learning system. Yep, you pour the data into this big pile of linear algebra, then collect the answers on the other side. What if the answers are wrong? Just stir the pile until they start looking right. And what George had been doing for a long time was stirring that pile. Every month he would send a new batch of data to marketing, and they still didn't know what to do with it. They never, no matter how much he stirred the pile, they never knew what to do with that data because it was just a bunch of numbers. And that really is what kind of an AI horror story looks like. And I work with startups all the time, and tech firms, and this is incredibly common. That someone will go away and try and solve some fairly ill-specified problem, and will solve it from a kind of mathematical point of view, but they doesn't ever get integrated back into the business. So I guess of those three things that we talked about at the start, where you've got a goal, a prediction, and an action. They do the prediction bit. They're given the goal, roughly, and they do the prediction, using machine learning, because that's what they're interested in, and that's fun. And the action kind of gets forgotten about quite often. So I'll just talk a bit about each of those things in a bit more detail. So so in this case, when I went and started working with this company, my first question for them was, what is churn and why is it important to you? And it turned out they didn't have a definition of churn. So they were, every person you spoke to was working on a different set of assumptions, and it turned out that a lot of the churn, so a lot of the customers were leaving, were just cancelling their subscription and then going back and getting a special offer and re-subscribing. So they remained users of the service. They just left in order to get a special offer. So they looked like churn, but actually they were staying with you roughly. So and there was various complications like that. But the problem was they hadn't clearly defined the parameters of what they were trying to predict. So George had been predicting those people fairly successfusly. Actually, he'd been predicting I'll come on to the prediction in a minute, but he'd been predicting something a bit off. But the second question was, is reducing churn your ultimate objective? It's probably not. Your ultimate objective is profit, revenue, shareholder value growth, or something like that. So if you might be able to say, okay, we'll reduce the price for all of our customers, and then none of them would ever leave. So if you had a zero price, no one would ever leave, probably. So there's always going to be a trade-off when you're trying to do these things, and you have to know what your goal is. Is it worth reducing the price for a customer who may only stay for an extra month, or may cost you more than that in terms of customer service inquiries and that sort of thing. So yeah. If you're doing this kind of thing, you have to know what your goal is. It has to be clear. And business is easy because often your goal is monetary and you can count that. So it's that makes things easy. Healthcare is hard. But yeah, if you make it measurable, it makes everything follow from that. You can work out whether you've achieved your goal. Second thing is prediction. So George, when I met him, bless him. He was really happy with his model because it was 99% accurate. He'd managed to predict nearly everyone who churned. But the way he'd been doing that was looking retrospectively at the data, saying what I know now can I predict who would have churned last year. And it turned out that the biggest predictor was, have they used the service in the last 3 months? And it's like, well, yeah, the people who haven't used the service have left. So it's easy to predict those people. And so, prediction is easy if you're doing it about the past. It's hard when you're doing it about the future. So he'd set up his machine learning model a bit wrong. So he was trying to predict what had happened rather than what was going to happen. You need to predict about the future for it to be useful. Otherwise you think your model is doing a lot better than it is. If ever you fit a machine learning model, I don't know how many of you are into this kind of thing, and it is 99% accurate, there's a mistake. Something has gone wrong. Your model is cheating somehow. So yeah, that's usually the case. So machine learning, this kind of wonderful branch of mathematics and probability that is very good at predicting things, but you have to kind of point it at the right thing. You have to make sure you're predicting the right thing at the right time in a useful way using the right data. Which model you use and all that stuff doesn't matter at all ever. Like just what matters is just doing it properly, pointing it at the right stuff. And also those predictions should tie into actions. There should be an obvious thing that you do with those predictions. And again, in the case of George, they didn't have that action. So without action, there's no point in doing any of this. So unless you've got something that you're doing with your predictions, it's pointless. And which they'd find out. They kept sending the CSV to marketing, and marketing didn't know what to do with it. So I went and spoke to marketing, which George should have done it. I mean, he had tried, but marketing weren't interested in speaking to this data scientist. So I spoke to marketing, and they said we're sending lots of emails. We send emails to everyone all the time. We with special offers. We try and tell them how great our product is. All sorts of things. So, my question to them was, if you knew somebody was going to churn, what would you actually do to stop that? And they said, we'd send them an email. And it's like, well, is that really going to work? Do you? I suppose. And the question was, do you know how effective those emails are? Or and they hadn't been measuring it. So there was the action that they had didn't have obvious impacts, and there's no reason why you can't just send an email to everyone. So why do the prediction? So what we tried to come up with was a more, I guess, structured way of looking at the problem, where you had, you maybe have 3 different types of email. You could, 3 different types of customers. You might have a customer who's leaving because they don't like the service. For those people, really, you should just improve your service. That's the number one thing you should do to stop churn. You shouldn't do any of this mucking around with marketing. Just improve your service if people are leaving because they're not happy. Make better programs, Netflix. But you can also, you can do some of the things. If you know somebody is leaving because your service is too expensive, you can maybe make it a bit cheaper for them. And there's a point where it becomes uneconomical to do so. But so we built a model that predicted what reason people might have for leaving, and tried to optimize a price so that for each user you could estimate to some extent, based on a kind of estimate of price elasticity, what the best price for them would be. So you make the prediction, this person's going to leave because of price, and then your action can be offer them a new price, that is just cheap enough to keep them there, and not so cheap that you lose loads of revenue. And there were various other actions that you can do, but the predictions have to be very closely coupled and aligned with the actions. And one of the best things we did was to bring the marketing people, the people who are in charge of doing those actions, into the team. They felt they understood the model. They gave feedback on it regularly. It wasn't just something you threw over the wall to them. It was kind of we formed a team where everyone was agreeing with each other roughly. And I think often those kind of human elements are harder than anything else to get right. If you're trying to build a system and you need to persuade somebody to do their job in a different way, then getting that person on board is essential. Otherwise, you will just be George sitting alone unhappily. So yeah, actions must achieve goals, and you need to be able to measure them, and you need to monitor them. In order to do all of this, you need to automate everything. So George had all of these scripts which he had to run through manually, and it took him hours each month, and it was very slow, and everything arrived too late. But you need to start following good software development practices and having everything run nicely. And I guess that's kind of the world of ML ops, which is this kind of bit of a buzzword on which is basically just making machine learning work, turning it into a system that works, which I would call AI. So in the end, we left and George was happy. We'd done all this work with him, made it clear what his goals were, made sure the predictions that he was doing were tied in with his actions, and made sure that the actions were achieving the goals, and measured that. And we did all of those three things, and we kind of had an AI system at the end of it. It wasn't perfect, it still needs a little bit of work, but it was better than at the start. So, just to sum up, AI goes wrong, always, or AI isn't even really AI, unless your goals are clear, your predictions drive your actions, and your actions achieve your goals. That's everything. Thank you.